Hello, everyone. Welcome back to Advent of Code 2023. It's day 14, which looks like the top of this depth first exploration of a problem space. So we're going to start heading down tomorrow, probably. This may be the root cause of the whole issue. We'll see. Anyway, hang on. My window's the wrong size. How dare you? There you go. Day 14, Parabolic Reflector Dish. You reached the place where all of the mirrors were pointing. A massive parabolic reflector dish attached to the side of another large mountain. Another large mountain, okay. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. This system must be what provides the energy for the lava. Told you. If you focus the reflector dish, maybe you can get it to go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. Okay, I understand that sentence. The platform is covered in large rocks of various shapes. Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move, and ultimately the focus of the dish. This sounds so complicated. There are mirrors connected by ropes and pulleys to a platform. The platform has rocks. That deforms the platform and controls which ropes move. Oh my god, okay? In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. Oh, okay. The rounded rocks will roll when the platform is tilted, while the cube-shaped rocks will stay in place. You note the positions of all the empty spaces and rocks. For example, yes. Start by tilting the levers so all of the rocks will slide north as far as they will go. Sure. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. And the hashes don't contribute because they're fixtures. They're like pillars or whatever. Okay, the total is the load. Okay. Tilt the platform so the rounded rocks all roll north. What is the total load on the north support beams? So I think we certainly could simulate this. Is there some more clever algorithm? The first observation to make, I think, is that moving everything to the west instead of the north is easier for singly linked lists, right? So we might want to transpose the input, then rotate things west, and then calculate stuff from the west instead of going from the top. Not a huge difference, but it'll be simpler. Wait, actually, would that make... I said rotate, but I was thinking of transpose. Is transpose rotate, actually? It's sort of not, right? It changes the dimensions the same way that rotation does, but instead of this like being rotated down to the bottom left and these being up above it, this would stay at the top left and these would go below it. Okay. I mean, I think that's fine because, at least for part one, we don't really care what order. Oh no, we totally do care. Sorry. No, we. As long as each of these rows becomes a column and we measure from the left, we don't really care what order the columns and rows are in. Or we don't care what order the rows are in. We would care about the order of the columns, but those would be correct. I think. I don't know. Maybe this whole transpose idea is dumb. How do you rotate a list of lists, like a matrix? I mean, maybe I just shouldn't do that. Maybe I can just like measure stuff from the top. But as I said, with singly linked lists, it's a lot easier to work with a list of the elements in the list, and instead of a slice cross-cutting across multiple lists, right? The other thing is, you don't necessarily have to actually do this rotation or tilting to work out a load, right? Let's for example, well, like let's look at this for example. What is the load of, you know, this column? It's 4, and we could figure that out by rolling all these up until they don't collide with something. But you could also just observe, look, there's 4 in a row. Sorry, it's not 4, it's 10, right? 1 plus 2 plus 3 plus 4, or the opposite, right? Okay, but it's like the triangular number. It's the numbers from 7 to 10 added up, right? And you can kind of tell there are going to be 4 of these because that's how many there are in this column. And you can tell how big they're going to be by how close they are to the top row, right? Like, let's look at this column here. There's nothing in this column, or in this little chunk in between 2 hashes. Here there's 1, and it's going to be at distance 6, right? Maybe row 3 is more interesting. There, in this span, there's 1 rock, and the span starts at the top, so it's going to cost 10. Here there's 2 rocks, and the span starts at 4, so the cost is going to be 4 plus 3, right? And so I think you just need to split the rows, or columns, I guess, or whatever, at hashes, basically, and compute the size of each group so that you can tell what offset each of them is at. And then for each span, based on its offset and the number of rocks in it, you can compute the cost, or the load. Right, you don't actually have to figure out, oh, it's going to go up to here, or something like that. And again, we could do this on the left after transposing, as long as we're careful. the first column here would be the first row here, and the second row, no, the second column, which we're supposed to calculate the load of, would become the second row. Is that true? Am I crazy? If you transpose this list, yeah, this goes here, this stays where it is, this goes here, yeah. Okay. But I wonder if we're doing ourselves a disservice by not modeling the whole tilting thing. Maybe part 2 is going to ask for a more complicated series of tilts. In fact, it seems sort of likely that it will, right? Because what else can you really do with this? I mean, on the other hand, if part 1 is like tilt everything north, and part 2 is like tilt things north, then south, then east, then south, then east, then north, like, what really are you even being asked to do in part 2? You're just being asked to repeat some of your work from part 1, I think. I guess you have to, if you only do things north, you don't really have to think about directionality. You can just like bias your algorithm in the northerly direction, and then if they start asking you for easts, you have to like have some way to roll in an arbitrary direction, which I guess is something. Okay. So maybe I'll just do the simulation. And actually do it in a direction agnostic way. Makes sense. All right, so I think one thing is that I want an array. Gonna have to restart GHCI because I have new dependencies. Okay. We're gonna model directions again. I think I'm gonna do it a little differently than I did last time. I had like data directions north, south, east, or west or something, because I needed to do more than just move things. I needed to like talk about what directions are attached to a pipe or whatever. This time I think I just want like data coord is coord of y and x, which are both ints. Type direction is a tuple of... It's a little annoying because... Well... Maybe I won't do this. Maybe I'll say... Like, a direction is basically just a coordinate, right? With the constraint that one of the entries is... absolute value is 1 and the other one's 0. So... I don't know. This seems fine. So let's say north, south, east, and west are all a direction. North is coord of, and again, we'll use positive y. Our origin is the top left corner of the universe. Positive y goes down, and positive x goes right. Coord of y would be -1 in that case, 0. South is coord of 1, 0. East is coord of 0, 1, and west coord of 0, minus 1. Oh, annoyingly, I don't have a good... these are... coordinates don't automatically add to each other now, right? Maybe I'll just make this be a dang tuple. And I'll just remember that it's yx. I mean, call me crazy, but I'm going to actually do this because I expect I'll be adding to these quite a bit. We're going to need to import data monoid sum. So this is a wrapper. Oh yeah, these don't exist. These are already gone. Sum is a wrapper around integers. I've talked about this once or twice in previous episodes this year. Actually, do you have to put this in parentheses? I think you don't when it's like the only term in an equation. Yeah, okay. Actually, let's go look at it in GHCI. So, we've talked about monoids, right? They're a thing that has a neutral element and associative operation. So, like lists, for example. You can say a list of something and a list of two, right? These combine as a monoid by concatenating their elements. Other good monoids include, I don't know, comparisons. So it basically, this is for kind of tie-breaking of lexical ordering, right? Where you might say, compare by the x element, and then by the y element, and then by the z element, and take whichever one was first. So like, eq, lt, gt is kind of a result you might get from comparing a four tuple. The first elements were the same, the second elements were the same. In the third element, we got less than. In the fourth element, we got greater than. So the result of comparing these should be less than, because the first two were ties. The first tiebreaker that wasn't a tie was less than, and we never actually look at GT. It's another monoid that exists. Integers can be a monoid under addition, right? Where 0 is the neutral element. But you'll see that if we write 5, 3, it's like, I don't know what type you want, man. Ints aren't monoids. As I said in that other monoid crash course, this is because ints admit two monoids, either sum and 0 or product and 1. So you have to specify which one you want. You can say sum 5, and it'll say, oh yeah, okay. You wanted to add together 5 and 3. If you said product 5, oh, you wanted to multiply 5 and 3. Oh, I didn't import it, but... But there you go. So these are different ways to look at integers. And I anticipate we'll be doing a lot of adding of coordinates, right? So I want to... And so we also talked... in that same episode about how monoids work for tuples. So suppose I had sum 5 and sum 3. The funny thing is you don't actually have to write 3. No, I guess I do. Type inference can figure most of this out, but... So here, the sums are implicit because it can tell they have to be the same type as this, and there's a num instance, so it doesn't matter, but... We now get for free the operation of adding together two coordinates, right? The first element was added 5 to 1, giving us 6. The second element added 3 to 9, giving us 12. So this is a bunch of boilerplate we won't have to write if I just use the existing tuple type. I guess I could make it a new type and then derive... use generalized new type deriving to get monoid, but I don't really want to. So there's our directions. and our coordinates. And we kind of want, like, I want a function called, like, tilt that moves things, that moves everything in a direction until it can't anymore, right? Oh, how big is, what does my input look like, by the way? 100 by 100. Okay, sure. It's just like not very lovely to actually write that function. Like, you could make a tilt by one step function, for example. That, like, when it sees a rock, it decides the position in the next array for that rock based on, like, okay, it's trying to roll west, what's one space to the west of it, right? If it's a dot, go ahead and move into it. If it's anything else, then don't move, and just iterate that function until the array stops changing. Pretty inefficient, though, right? I don't even know. I guess we could actually use a mutable array. And just, like, make sure we're scanning rows / columns in exactly the opposite direction as the rocks are moving. So if we want to move rocks north, we should scan the rows from north to south. And then every time we encounter a rock, a rolling rock, we scan upwards until we find the place where it will come to rest, erase it from its old location, and put it into its new one, right? In that way, we can do this tilting in one pass. And reasonably efficiently, I think. I mean, it won't be perfect because we'll be wasting work. Like, if there's, at the far south of the grid, if there are 10 rocks and there's no space at all in between, like, the whole rest of the column is empty, we'd move the bottommost rock by 90 and then go back and rescan that whole 90 for the second rock, and, like, we would do 10 times 90 work, whereas, like, a really smart algorithm could have just done about 90 work or 100 work or something. Actually, it's not so hard to come up with that smarter algorithm, is it? You could, as you're scanning from north to south, compute or keep track, let's say, of the position to which a rock will roll. And as you scan over empty space, you leave that position the same. When you run into a rock, you say, oh, okay, cool. I'll roll that up to the position that I've tracked as the, like, bottommost empty space. And then you can just move the rock that far instantly and update the bottommost empty space to be lower by 1. When you encounter a non-moving rock, you can just update the bottommost empty space. So I think that's actually a single pass Yeah, that sounds kind of cool, right? It's a single pass over the entire array. We only ever look at each cell. We read each cell once, and we write each cell at most once. Right? It's hard to imagine doing much better than that. And that sort of makes me think, what if the part 2 is like, okay, you actually need to rotate these things in a circle 1,000 times. Go northeast, southwest, 1,000 times. Or something like that. Maybe that's somehow enough that it is computationally difficult for the naive solution? I don't know. I'm going to have to go look up the Freen type interface for arrays. I want to look up marray, I think. Not data text array. In array, here we go. So this is a module, an interface to mutable arrays. God, it's so big. I'm gonna want data array st. St is gosh, what is st? Well, the documentation will tell us, right? The st monad allows for destructive updates, but it is escapable. So it's kind of a way. Haskell is an immutable language. You can't modify anything. St is a way to avoid the overhead of not being able to mutate anything, having to make copies of stuff all the time. You declare sort of to the compiler, here is a computation within which I want to be able to pretend to mutate stuff. And the types make you promise that you will never allow data to leak between your little mutable section of the world and the normal section of the world. And that allows the compiler or the runtime system or something like that to actually do destructive in-place memory updates within this region, because it can prove that nothing else outside the region can depend on it. And so this lets you write a pure function whose implementation is actually impure using st. And so putting an array in st is a way to give you kind of access to an efficient block of memory that you can index and modify. So I'll definitely have to brush up on all this stuff to actually do it. But I think I don't think I want a U array. I just want an ST array. Yeah, I want this, right? What is the difference between these two? These look the same? ST array S&D and STS is instance of marray, and so is this? What's the difference? Are they defined data array base, data array base? These are the same. But if I mouse over them, you can't see it, but I'm looking at the tooltips. They're in the same file, but offset by 12 lines. So, I see. The trick is that the ST here, one of them is lazy ST and the other is strict ST or something. I don't know what the difference is there. So this one is ST lazy and ST. So the lazy ST monad, what's the difference? Safe is now the default. Please use control monad ST lazy instead. Wait. Oh, I see. I see. So it's the same operation as control monad ST, but it delays execution of ST operations until something outside of ST needs the value from inside ST. Okay. I don't think I care whether I get lazy or strict. I probably should get strict. It'll just be a little more efficient, and I will need the entire thing, I imagine. Okay, fine. So marray is... What are the functions I can have for marray? New array, new list array. Every element initialized to the supplied value, so we'll fill it. New array. Now, new gen array. This, I assume, is not in the version of array that I have. We talked about this last time I used arrays. Since fix me, huh? Okay. Map array. Yeah, so get bounds. Sure. So we can ask, like, we can check whether an index is... I shouldn't ever need to check whether an index is in bounds, right? Are there folds over arrays? There aren't really, huh? Well, actually, does it have some instances that I don't know about? Doesn't look like it. It doesn't... Well, marray is an instance, is a type class. The actual array I'm going to have, as we said, is an... Do I want... Which one is this? Is this the lazy one? Yeah. So this. I'll have an st array. And the only types it's an instance of is marray and eq. Or the only classes it's an instance of. And there's no functions in here, really. Those are all provided by the array, the marray type class. Okay. So where's my new array thing? Here it is. Do I want, like, new list array or something? I think so. New list array should be fine. I can present... I can parse the input into a list of lists, concat that list of lists to get a single list in a row major order, and then pass that to new list array. I think that makes sense. Maybe I'll do that first. Data feature, again, is empty or wall or boulder. That's a boodler. Show, eq, or an enum all seem good. I mean, we could look at what they're called in the problem, technically, right? Like, they're called rocks. Rounded rocks and cube-shaped rocks. Like, who wants to bother with those names, right? So I'll call them empty, wall, and boulder. And, you know, the walls don't move, so that sounds about right. So I think... I was going to say that my input should... Like my input type here, the thing that I have prepare, produce, and part 1 and part 2 both consume, should be, of course, an st array. But I don't think you can... Can you make those? Like, does that actually exist in real life? I think it doesn't, right? You can only create them inside the context of of some monad, right? Yeah. So we could have an STS of ST array of feature. Actually, hang on. Could I don't think I could, like, unbox. Like, it would be a little more efficient if I just stored ints or something, right? But I'm not going to do that. Plus, we want non-strictness anyway. No, we want strictness. Okay, I've already forgotten. I'm looking at ST array in ST, and this is ST. Yeah, this is the strict one. Control monad ST, I think. So I guess we need some more imports. Import control monad ST. I mean, I need at least those things, right? That might be it. Import data array ST array. Is that the right data array? Oh, ST, excuse me. The functions I need here are ST array, run ST array. That would let me take the array out of state when I'm out of ST when I'm done with it. Do I need that? Not really. Do I need anything else from this dang old? No, I don't think I do. I do though need, I guess. Well, run ST should be like this, right? This should give me run ST, I imagine. How have I lost? I've lost track of my STs somehow in the documentation. Yeah, run ST is the field accessor, so I'm getting that for free from the imports. Which is, I think, all I need from ST. From data array ST, I just need the type, I think. Really? And then for, yeah, I guess that's true. And from M array, I need new list array. I need several things. Import data array M array, right? Yes. I need new list array. I need read array. I need write array. And I need get bounds. Maybe I want get a soaks as well to get the key value pairs in the array. That way I don't have to reiterate over the array again inside of ST where everything is awkward and imperative. I can just compute the whole array and then say, give me the soaks of the array, and then take that out of ST into the normal Haskell universe for me, right? And then you can just map over them and for each one compute the distance from the wall you were looking for, right? I think that makes sense. Yeah, I was just thinking whether there's... do I need anything else? No. Whether there's some way to trick the array interface into giving me a view of the array with like the same elements at the same positions but using a different indexing scheme to let me kind of do what looks like rotation for free. That would be kind of sick, right? I I don't think there's anything that does that efficiently, though. We have freeze and thaw, map. Oh, wait. There's this function called map indices. Does that make any sense to me? What does this type mean? If I and j are both indexed, why does it want two i's? I get that it wants an I to j. It'll turn AJE into an AIE. But why does it want two i's? That's this. Lower and upper? Oh, is this like computing a... okay. It looks like it is just copying the array and... yeah, it's implicitly giving you a slice of the array from lower to upper for a reason that's unclear to me instead of the whole thing. I mean, I'm sure that's a useful operation. I don't know why it's not documented here what it does. And it isn't really what we want anyway. It's not efficient. It just seems like it would be a cool way to rotate so that we can always view the arrays coming from the same direction. Oh, wouldn't that be cool? Oh well. So, I wonder if we actually need a little bit more, not abstraction exactly, but more detail about north, south, east, and west than just like how to traverse in that direction. I forget if it was like last year or 2 years ago that I was doing like a scan. I think it was in Kotlin, so it must have been last year. We had like a forest, and you were supposed to traverse it like from west to east, and then north to south, and south to north, and do something with the results. And like you wanted to scan each row as you were moving through the rows from north to south. So it would be kind of nice for north to say, like, you know, if you want to move in the northerly direction, start at the bottom of the array. Right? I think, though, you can derive that information from these directions here. We could say to figure out where to start a scan for a direction, take your initial guess as 0, 0, and then scan in the opposite of that direction until you wind up outside of the array, and then like go back one, right? And that's where you start. So to scan to scan in the northerly direction, rolling rocks to the north, you should start at the south of the array, which means moving in the 1, 0 direction until you're outside the array, right? But I think you can do that as some kind of multiplication with the bounds of the array, so you don't actually have to scan to figure that out. Maybe not. Because... like a 1 or a 0 in a part of a direction means that you can start at 0 in that dimension, right? And if you see a -1, you should start at the max of the array in that direction. I mean, I guess that's fine. Or wait, do I have it backwards? To roll rocks in the northerly direction, you actually need to start at the northernmost part of the array, because we're going to be scanning the opposite of that direction to track like the furthest position that is currently safe. Or occupiable or whatever. Honestly, I'm starting to think that a tuple is not a very good type for this. I'm changing my mind again about the representation. I think I might want data coord of A is a coord of Y and X, both of type A. This way I can do things like fmap through them and get both elements at the same time. Am I going to want these to be applicative? Like, maybe. It seems like it might be nice, right? Yeah, probably. Where find ... name star.hs xargs grab. What day was it that I used generic, please? All my functions, all my files are called main.hs. Let's not scan through stack work or something. Okay. Day 7. So let's go revisit how that works. Generic 1 and generically 1 with deriving via. And then we can write this. We get applicative that way. Okay. Let's try that. It's going to be a lot of pointless work adding these imports if I change my mind about the representation again. Does that make sense? Oh, of course we have to put generic in here. Okay, so good. Now, a direction is a coord of int. I think we can safely specialize that. Okay, so that all compiles. Good news. We now have applicative for coordinates, so we can do things like, we can add 2 coordinates by just like using lift A2 plus or using the applicative operators. So we wanted a way to know the directions to scan through the array in based on a direction, right? And then we need to know like a perpendicular direction to, gosh. I wonder already now if this is the wrong type for direction, and I should just say north, south, east, and west. And then I can have a function that derives the relevant stuff. The delta and the start and the perpendicular, kind of. Oh, I don't know. Let's do it. Let's just define the type again for the millionth time. Deriving show eq ord and enum. Don't need that anymore. And we can get like, I don't know, scan data scan is scan is a 3-tuple, I think, of unit, which is a coord of int, which is the direction to scan in. Init, only off by one letter. That'll be fun to typo or misread. Actually, I shouldn't use init. It's in the standard library with shadow something. Start pause is a actually, can we derive index from this as well? I'm gonna need that, right? Start pause is a function from coord int to coord int. We're gonna have our, I think our array can be indexed by coordinates. Actually, can we even derive ix? Maybe not. How does that work? Haskell derive ix, does that make sense? Only possible for enumerations and the single constructor, okay. Data ix. So, but like, can you derive? Yes, derive instances of ix using a deriving clause on a data declaration. Possible for enumerations and single constructor data types whose constituent types are indexes of ix. Yes, so I think I can do that. I can index an array by coords. This is important because I plan to pass start pause like the upper bound of the array and have it determine, okay, based on that, here's where a scan moving in this direction should start. Normal, i.e. the orthogonal pointing direction that we can move to once we finish scanning a row or column, move to the next column or row in this direction. I think it makes sense for this to also take I think it can just return a direction, right? or a coord, a direction. It could return another coord event, I suppose, and you would add that to your starting point for the previous scan. But, yeah. I guess I'll just have it take coordinate and return coordinate, just like, Well, that means I can say start pause and normal both have this type. And we basically can't derive anything for this, right? It can't be showable, it can't be eeked, it can't be anything for a scan. What we want is a function scan takes a direction and returns a scan. And we'll just write up, scan D is case D of north. So to scan where the unit is this, to move in the northerly direction is that. No comma. The start pause is origin. We're going to have several like things in a where clause shared by all directions. So we'll say origin of anything is chord 0, 0. I mean, I think what does index have? Yeah, it's not so easy. Yeah, so we'll just say chord 0, 0. Why did I write start pause equals origin? I should just say origin, right? And origin takes an argument and ignores it, right? If you're scanning... Oh, no, this is wrong. If you're scanning northward... No. Yes, if you're scanning northward, if you're pushing the rocks to the north, you need to start in the top. So 0, 0 is correct. And the delta, the normal range is like east, kind of, right? Where east of coord yx is, oh, hang on. East is plus mapped over coord 0, 1. Does that make sense? Shouldn't this... I want to add 0 and 1 to a coordinate, right? What is the type of east? East of C is... I was missing... Okay, I missed this app thing. I see. So actually, what it would be better to write east of C is lift A2 plus applied to this, right? And we need to import lift A2. Import control applicative lift A2. Okay, sure. And we'll also need a scan function for moving north to south for the east. So we'll say south is lift A2 plus coord 1, 0 to increase the y. South is a scan coord 1, 0. So here we're moving the rocks to the south, which means we're scanning starting from the bottom. So we need to use the y element of the highest part of our array, the max bound of the array. So lift A2 of times on coord 1, 0, right? Use the top of the array for y, but ignore it for x and just start at 0. Yes. And this can also scan to the east. Okay, that type checks. Good. If you want to scan to the east, if you want to roll rocks to the east, you should start on the east side and move west. So it's still coord 0, 1 for the movement. The way to move to the east is like this. But to roll the rocks east, you have to start on the east side. So we want lift A2 of times coord 1, 0. And we want to move south. Lastly, west is a scan coord 0, minus 1, origin. Wait, how can I be starting? Oh yeah, that's right. North. Yeah, to scan north, moving rocks to the north, you start in the northernmost position while scanning. Likewise, to move the rocks west, we start in the westernmost position, and those are both in the origin, so that makes sense. Okay. And then we scan southwards from there. Origin south. Yes. I feel like I'm making things more complicated than they have to be, but I always have. Last time I had to do this kind of thing, whatever year that was, I struggled some with defining all the various ways you can. Oh, it was the one about like treetops, right? It was like I remembered it was a forest, but it was like skyscrapers, where from a position you had to be able to look in all 4 directions and like scan until you ran into something taller and like count how far away that was or something. I struggled with that a bit. So this is the important information about a direction, I think. And so I kind of want I kind of want to define the roll, like do roll on an array function next. Right? Roll things in this direction and see what happens. It's going to be the hard part of today, I hope. I hope there's nothing harder than that. So let's try roll. Takes an st array of coord of int. It takes a direction and an st array of coord of int. And returns sts of st array coord of int. Roll is undefined. This type is legal, right? No. 2 more arguments. Oh, right. I have to say it's indexed. Okay. Type grid of s is an st array I need AEI. Is that the order it goes in? IEA. Okay, an st array takes s, the s type for the st, then the index, which is pair of coord. No. It's just coord of int. And it saves features in it. So I have a grid of s, and it returns an sts of grid of s. Does that type check? Oh. That's a nice warning, I guess. Wait. Suggests that st has constructors or class methods, but it has none. Doesn't it have run st? I thought that was a... The import of run st is redundant. In what way? What do you mean it's redundant? Because I'm not using it? Is that all you mean? I guess. I somehow convinced myself... I don't know. I mean, when I look at the documentation... Oh, I see. I got confused. Inside of st, there's this little thing here, run st. And I was like, oh, that's the definition of the constructor. But it's not. It's just, it's a law. And then you scroll down and you get to run st. Okay, so it's a free function in that module. Roll of D and G is, I mean, it's going to be, buckle up, we got some stuff to do. 4? Which probably comes from data foldable or something. Where's 4 from? Data foldable. Okay. So for each, I don't know. Maybe I don't need to do a for. Maybe I want to do it, just do a fold. Fold M. All right, I'm just going to start by writing a let. Let some things I know are useful. Let scan unit origin normal. Oh, I gave these names here. Okay, so let S be scan of D, I guess. And I guess I want starts to be what data array st. Okay, and in M array, where can I get the even the bounds are in M. Okay, so I can't let them. I have to be low, high from get bounds of G. Do, I guess. So that'll give me the bounds of the array. I can let... no? Starts... No. Okay, I can let this. Let starts equal take while. Where's index again? In range. Did I import that from data ix? Not yet. Okay. Import data ix. Inbounds are in range. In range bounds of iterate lift a 2 plus of the unit of the scan starting at the start pause of the scan, right? Is this type check? No. Start pause S needs to know the high bound. Okay, good. Yeah. Okay, so that seems all right. We've got the start positions for all of our scans. And I think now we kind of want to iterate over each of them, modifying the array, right? For I guess I say starts. Is that how for works? Yeah, it takes a T of A, which for us is a list of A's, and then a lambda. Okay. So for each start position of the array, oh, actually, you know, I could just like, I could return unit here and say it's going to be the same array, but I guess it would be convenient to get the array back. Maybe. I don't know. I'll return unit. Um, the funny thing is, you don't even actually have to modify the elements if you were doing this tracking in the right direction. I don't know. You could compute, like, every time you're about to move a rock somewhere, you could compute, oh, here's where I would be moving it, and this is the weight that that rock has, right? God, it's going to be so stupid if I don't need to roll things in directions other than north, but it's an interesting problem, I think, right? Might as well implement it for fun. So for each start position, well, I don't think this is quite right. Let's write, for each starts, go of... I want to save... I want, like, a parameter to go to be... Well, no, I guess this is fine. Loop start, I think, where one of these starts is the position we're currently considering, and the next is the furthest location that we could push a boulder into, right? Well, the problem is I want... I want access to bounds here. Let loop of... Maybe do it this way. Let loop of cur vacant equal do, probably. I think we want to start by checking if the current position is in bounds. And if it's not, oh, this is the one day I took out lambda case. I think I want it now. Yeah, that, okay. I want to say, or wait, no, I don't need, bounds is already just like, it's not, there's nothing monadic in it right now. Okay, let's leave this out for now. Start, okay, so if not in range bounds cur, then there's nowhere to push, there's no more rocks to push. We can just say it is nothing. Otherwise equals do. we need to actually read something, right? So let's look at the current position. God, do I want lambda case now again? I just put it in and then deleted it. Read array. What the heck order does this take its arguments in, man? Read array takes the array and then the index. Read array G and cur. And then pattern match. Bind that to a function, that function being pattern match on this. Yeah, I want lambda case after all. It's not much trouble to add back in. If it is an empty, then we should record what must we do? I think we should leave alone our vacant position, because whatever was vacant before is still vacant based on this empty. So I think really we just say next, where, come on, well, why won't where tab complete over here? Like, wouldn't it be legal for me to attach it to roll? Huh. Okay, well, we'll leave that for now. Next is going to be just move on to the next. Well, actually, I don't know if anyone's going to use next, right? Loop. Update the current, please, to. We call it unit. Oh, hang on. The starts shouldn't be using unit. They should be using normal, right? Phew. Unit of S applied to cur and leave vacant alone. If maybe I don't even need this do. I probably don't, right? And now suddenly it's not happy to let me put a where over here. I don't know why. If we see a wall, what must we do? Loop of unit S cur and unit. Really? I guess just unit S cur again? No, that's wrong. Well, it's fine. If there is something on the other side of that wall that's a wall, then I won't care what the vacant space was. If what's there is a boulder, either way, I'll be updating this. And if it's empty, then this will be correct. Yeah, so this seems right. And if there's a boulder, then we actually do something. We say do write array G vacant boulder, move the boulder into the most recent vacant position, and then we're going to call loop of unit S cur. This unit S cur thing I want like in a where clause somewhere, and for some reason I can't figure out where to put it. There must be some syntax error I have here. I don't know. Loop of unit s cur, that's our new scan position, and our new vacant position is unit s vacant. Move one step further from where we just put a boulder, right? So this makes sense. It shouldn't compile yet. Okay, you're upset about types. Why? There's no... It really looks like something is wrong with my indentation or some syntax somewhere. But what could it be? It looks fine. I mean, that would explain why my editor was telling me where can only be here. It can't be over there. You can define functions. Oh. The issue is I don't have an in for this let. In. Loop start, right? Okay, now the syntax is right. Normal is applied to too few arguments. That sounds about right. Normal s origin? Wait. Oh, right. Normal already has this. I can just say iterate normal of s. And then apply that to start pos s high, right? Unit is applied to two value arguments. But its type, scanned chord int, has only one. Well, actually, I mean, why is unit a chord of int? Why isn't it like all the others that takes a pair of things, right? Why don't those all just take 3 chord int to int? And we'll say by is a function from chord. I don't have to give it a type. By of O is lift a 2 plus of O, right? So here we can say by this, by this, by this, by this. Okay. So that all now type checks. Very low confidence that it's correct. But it doesn't look insane, and it's not super complicated, right? So where can I write a where? It can go here. This is wrong, isn't it? I guess, can you not... I thought you could attach a where to pretty much any named function. Or pattern matching context, and that let would be such a can I not, like, where next is unit s cur? Like, is this legal? It's totally legal. My editor just doesn't know where to put it. That's in scope, right? Yeah. That's where I wanted to put the where, but like none of the tab stops it was suggesting were that one, so I have to do it by hand and try not to mess with it too many times. So I guess we could test this on some smaller inputs that we write by hand, right? We could even do this in GHCI. Run st of do. God, that's going to be really complicated. Let's do this in a real file. Test is... Are arrays showable, do you think? It doesn't matter, I'm calling a soaks to print it. It is a list of pairs of index and element. So test is a coord int and feature. Test is run st do. Now my recollection is there's some funny business with dollar signs where like run st has a strange type, and some of the stuff you're used to writing for for most things in Haskell doesn't work with run st. I think they special case dollar sign to work normally, but if you perturb this at all, it like doesn't work. Like if you say foo compose with run st of do, it's like God help you. So run st of do, G needs to be a new list array. Yes, new list array. I'm gonna make it a 2x2. Am I so brave? Maybe a 3x3? Sure, 3x3. Takes coord 0, 0 up to coord 2, 2. And my grid that I have in mind is a boulder in row 1. We'll roll things upward. Boulder. No, not boulder. Wall. Empty. Wall? Hang on, is something wrong here? I'm still not sure about the direction I'm doing my scans in. Like, I actually want, when I'm rolling boulders north, I want to start at the north, which is what I have, right? Origin. But then I want to walk south, right? So actually, this next, yeah, this is the problem. Now that I've made unit a function, is my unit exactly backwards in all cases? Because if I'm scanning from north to south so I can roll rocks northward, I'm always stepping south, and I'm always updating vacant by moving it south as well if I do move it, right? So I think actually this is crazy, but call me crazy, but I'm gonna fmap negate over the. Why did I say O, by the way? What a weird name for that. So now north is gonna say, yeah, okay. It seems very sad, but all right. Wall, empty wall. Empty boulder. Boulder? And then boulder, boulder, empty, I think. I think that's an okay tiny little test case, right? This boulder should roll up. These two boulders should roll up. This boulder should stay where it is. You know what we could do is we could also like double check that we're definitely moving it to a vacant spot, right? Case read array g vacant of. If it is vacant or empty, excuse me, do all this stuff. If it's anything else, error, unexpected, show f at show vacant. Sure. So here's my new list array. I want now to, did I call this function roll? Yes. Roll north G. Pure of, no. Get a soaks of G. That'll return an ST of a soaks, and run ST will pop it all out. So, okay, couldn't match type M of feature with feature. In the pattern empty. Oh, I see. Read array G variant bound to lambda case. Okay. Couldn't match type feature with list of feature. We actually got an ST array of list of feature here somehow? Oh, of course. We're not actually supposed to give it a nested list. We're supposed to give it a list and it will impose its ordering, or it will impose rows naturally. So that's cool. What is test then? Error. Unexpected boulder at 1-1. There is a boulder at 1-1. I can't argue with that. Well, so what should have happened? I should have scanned... It looks like column 1 worked out fine. Actually, wait a minute. Well, first of all, like, no error should ever occur, right? This error means, regardless of what my grid was, something went wrong. But you know what? Let's just double check here. What are the ASOCs that I get out of this? Ambiguous type variable. In new list array. Eh? You were pretty happy to make a list earlier, right? Use a type annotation to specify what A0 should be. I see. The issue is that without something to tell it what type of array I want, it doesn't know. Roll was telling it that. I said I wanted a grid of S. Well, G has type ST array. The thing is, S, I mean, I don't know what S is. I can't... I can't tell you that type. It's impossible. You made it impossible by not allowing me to mention S. Maybe I can just say S and it'll implicitly be for all S. I don't think that'll work, but we'll try. It's indexed by coordinate and it stores features. Are you happy now? No, of course not. So it's happy with that. So if I just said, like, don't do anything, it's kind of hard, but I could, like, comment all this out. Well, I could say const unit applied to do, and then it won't evaluate any of this. It'll just return unit. Oh, but now it can't figure out the types? It can't figure out the type of roll anymore because it's not doing anything. What? Ugh. This sucks. I hate ST. Okay, comment all this shit out. Okay, so now it type checks. Roll supplies the type that we need, but doesn't do any actual work. And if I say, what is test? We expect that 2, 0, which is this, because y is 2 and x is 0, should be a boulder. What do we actually get at 2, 0? A boulder. So that looks right. Along the top row where y is 0, we have wall, empty, wall. Yeah, so I think it understood. I supplied these elements in the right order. Well, you know what we could do is we could debug trace inside of roll, I guess, to see what moves we're making. Import debug trace. Why are you saying I don't need in range? Wasn't I using that? What do you mean it's redundant? I'm using it right here. Hello, are you high? Oh, is it in bass? I see, okay. Or prelude or something? I'm not using sums anymore, that's true. Trace. Scanning. Show cur. Yeah, okay, so scanning makes sense. And we'll trace like kind of nothing, right? What happened there is we did nothing. So I guess we'll just trace empty. Well, I guess I want to know a little bit more here, right? Which is updating vacant to show next, I guess. Okay, and now it's exciting. We say trace boulder moving to vacant, which is show vacant. And do nothing. Then trace, I'll just say boulder again, new line. Updating vacant to show this. Okay, that's, I thought, getting somewhere. Line 53 here. Oh, show of unit S variant. Okay, so what if we reload now and ask for test, please? Scanning 0, 0. Updating vacant to y is 1, 0. Yeah, I mean, that makes sense. You found a wall, right? Scanned 1, 0, you found it empty, so you left vacant alone. Scanned 2, 0, you found a boulder there. You moved it to the vacant coordinate 1, 0, and updated vacant to be 2, 0, the position where the boulder that you just touched went, or was from. So that makes sense. Where it just left, that makes sense. Then you started on the next column. You scanned y0, x1, finding empty. Then you scanned y1, x1, and found a boulder, which you said, I know a vacant place to put that. That's y0, x1. And the new vacant position. Oh, of course. When I move the boulder, I don't erase the spot where it was. I only put it to its new space. So if I say right array g cur empty, that should take care of it. Nope. Why? I thought I just immediately figured it out, but it's exactly the same problem. Okay, well, we'll write another little trace thing here to indicate what we're doing. Trace folder vacating show cur. So, I mean, I don't think this will tell me anything that interesting, but I guess it will. So on X... Oh, actually, we got further, didn't we? I just realized. It's still errors, but... Well, no. Maybe y2x1... Yeah, y2x1 is where it broke before that fix. And now it's breaking at y1x2. So it made it through the first column and the second column. It's breaking on the third. So I have this error unexpected boulder. What is that all about? Well, that's true. I guess I haven't really handled the case that a boulder can't move at all. I correctly said, oh, the vacant place to put it, that's where you're currently standing. But I did then say, oh, there shouldn't be anything where I'm putting it. So I guess, actually... I think this is fine. When not equal... Oh, that's not how you do it in Haskell. That's the closure's not equal. When cur not equal vacant... Then we print this error. But otherwise, it's not an error. Import control, oops, monad when? Okay. And we get the whole array back. Okay. And I think it's the right one, but it's so hard to tell with all the debug trace output, right? Oh, no, no. The debug trace output is separate. We can look here. Okay. So what do we expect in column 1? We expect wall boulder empty. And we get wall boulder wall? Oh, right. We should read this left to right, not... Okay. So wall, boulder, wall. Yeah, that makes sense. These two slid up. Then y1 should read boulder, boulder, boulder. Yeah, I agree. And y2 should read empty, boulder, empty, right? It's empty, empty, empty. Is that correct? It is correct. They all should have gone up. Okay. So I think rolling north works for at least that very small input that I wrote. I wonder, like, let's just take this input and try rolling it, you know, west. It shouldn't be very interesting. Actually, I don't think it would be interesting at all. Roll it south? I don't know. So the top row reads wall, empty, wall. That seems right. Second row should be empty, boulder, empty. Empty, boulder, empty. And then we get boulder, boulder, boulder. Perfect. So I'm reasonably convinced that roll is correct. It's far from a proof, and I'm going to leave the traces in case I run into a bug with the real input. But we can now do this. Yeah, and I guess I mentioned that you never actually need to move anything. If you were just doing part 1, you could just, when you would move a boulder, you can say, well, that's definitely its final resting place. So let's just compute the load it applies. But since I anticipate part 2 will ask us to move things multiple times, I am updating the array. Okay, cool. So let's write a little parser, I guess. Oh, let's put in overloaded strings as well. Although I barely need it. RE sum what else do I even need? A sum? Maybe? Yeah, we don't need run st anymore because I don't have it, but we will. Prepare, I think, is just going to be from maybe error no parse equal match input, where input is some row separated by new lines. Row is some feature. I guess our input is going to be a list of feature. And feature is a sum of a list of f into s, where f and s come from zip empty wall holder with dot hash o. Assume? How about a sum? From maybe's not in scope. Sure. Variable not in scope? I didn't take that from... Oh yeah, that's an important one. Couldn't match type... FB0 with char? What? Ah. I have a character there, which is not a parser. Actually, this shouldn't work. Pure of S is a mistake. Overloaded strings won't help me here. I actually need sim. Okay, so that parser works. So let's just check, does it parse correctly? Yeah. The entire input file parses to this big old blob of garbage. Great. I mean, I guess I can placate it by putting an underscore there. I don't need it. It's true. I need to know the high, but I don't need to know the low. I hate getting rid of these traces. I don't know. I think I'll leave them for now. They're harder to comment out than these are. So part 1 is actually now fairly simple, I think. It's f's is run st of do. G is new list array chord 0, 0 up. Oh, this doesn't need to be okay. Up to chord of y first, so that's length f's minus 1. And length of head f's minus 1. I kind of hate it, but that's our new list array. I think just f's, right? Because new list array just takes a pair of indices and a list. Okay, so that's good. Let's roll G to the north. And then some map load into get a soaks of G, where load of coord Y, ignore the X, boulder equals Y plus 1, I think it was a... Because the first row is supposed to count for 1, right? Or is it supposed to count for 10? Number of rows from the rock to the south edge. So actually, our coordinate system that makes this y0 is sort of inconvenient. It would have been nice, actually, if I'd used one index to raise. I still totally could, right? It would be a very small change. Well, I'm not going to mess with it. We already have it working 0 indexed, right? I'd have to fix this. But couldn't origin just be 1, 1? It's fine. Leave it alone. Don't break what's not broken. Nor fix it for that matter. So I guess we should say let we should let width and height be something, right? HB width be length of head halves. So this should be height minus 1 is the maximal element in the array, or index in the array. And this should be width minus 1, right? Now when I have a y, I believe I can say y height minus y and not add 1, because y is 0 at the top. Yeah, this makes sense. And load of anything else is 0. True. We have to call concat of f's to turn our list of lists into just an ordinary list in the right order. Coord input? Oh no, what? Oh, because I said it should return input. It actually should return int, though. H and W are not in scope? What? Oh, that's true. They're in this where clause. Well, let's just put it here then, shall we? Oh, the import of RE, yes, that's true. Since I defined my pattern all in one place, I don't need to give a name to the type. Okay. Well, I imagine this won't be correct, but let's see what happens. That's a number. Pretty happy to have gotten a number and not an error. Is this plausible? It's 100 by 100. So if the entire top row all had rocks in it, but nothing else did, it would be 10,000. Yeah, this seems like it could be the answer. Too low. Yeah, well, I really have no idea how to debug this. We could try on the test input, I guess, right? Do I still have my... My little test array, I don't. I deleted it. The amount of load caused by each rock in each row. Sorry, just looking at the input, the problem again. You know what would be nice is a function to print the array to make sure that I've rolled the boulders correctly. And then if those are correct, I could debug my load function. And if they're not correct, I can debug the roll function. So let's try that. Show grid is a function from grid of S, I guess, for any S? No, I should just make it take the bounds. No, I don't know. I'll make it take the whole array. Why not? Grid of S to STS of string. We'll just output one string. A list of string. The rows, the lines you should print, I guess. Show grid of G is do. Coord. Well, we know this will be 0, 0, I guess, right? But might as well be explicit about it so that if I ever do change my representation, this function will break at compile time. Or the first time I call it, I guess, it'll break. Coord 0, 0 and coord height width get a soaks of G. And then I want to say pure of do, and now we're in the list monad, right? Y from 0 to... Actually, these aren't height and width, are they? They're like max 8, max Y, and max X. So from 0 to max Y, zip that, well, no. Pure do again. We're gonna produce X from 0 to max X. Pure of, no, not pure. Oh, no. No, it's fine. I already have the assocs. Oh. Right. This is bounds. I need to get the assocs as well. Ugh. Well, now I can't really be in pure, can I? If I need to actually read the array at this position. So this is, I meant this to be get bounds, but it's not so easy. I guess I want like map m instead of pure, which of course these days is called traverse. So, okay. For this lambda y, for this lambda x, I think this should make a list of st actions and traverse those into an st of list of character, right? Here I want to say read array g of y chord yx, I think. 4 is not in scope. Give it to me, please. Fold wasn't export 4? Where is it? Data traversable. Okay, fine. Couldn't match feature with char. That's true. You're right. Show feature of read array g. Fmap that in, where show feature of f is case f of empty should be a dot. Boulder should be an O. And wall should be a hash, please. Notes from monad fail. Oh no, from a do statement. Oh, okay. Well, I guess that's fair enough. I'll just say I don't care then. So I don't actually have a good way to smuggle out a string in this the way I usually do things. It assumes you're going to want to call show on the result. Doesn't it? Yeah, print. Oh, main is due. I is from prepare of read file of the input. Print part 1 and part 2 of I. But I'm also going to print debug of I this time. Debug. No, don't print. Put stir it. Debug. It's annoying. I'm going to repeat some stuff in part 1 here. Well, yeah, okay, fine. Well, part 1 and part 2 are both going to need to make the grid, right? So I guess what I can say is toArray is a function from list of feature from input to STS. And I already have a name for this type, don't I? It's a grid of S. Two array of F's is, oh, it's an STS of grid S, I think. Yes. The annoying thing is I'm going to need the length and height here. But I guess I can get those from the array after. Okay. So let all this stuff in this. G is from two array Fs. I need to compute the max and min from the bounds, right? Get bounds of G. And now I can say max y minus y plus 1. Equal? Let. Error line 104? Oh, I didn't finish writing debug. Sure. Debug is a function from what even is it? I guess it's a function from input to string, right? Debug of f's is run st of 2g comes from two array f's. Roll north g, just like our part 1 does. But then we say show grid of G, right? So show grid of G, what is that going to do exactly? Show grid of G? Because G, show grid takes a grid, which I have, and returns an st of list of string. Oh, I guess I want an st of string, though. Show grid unlines over that, please. Compiles. I don't need the max x here. That's interesting. Fair enough. So if I run this, what happens to me? It's going to be like a huge thing, and it's completely wrong. Right? It's like nothing moved at all. I mean, there's a lot of stuff pressed up against the north wall, but not. There's lots of things that are wrong, like this O just floating here in the middle of space for some reason, right? Well, wait a minute. Why does it... Why did it stop at y22? Like, it's wrong even before it got there, but... Okay, so it's scanning... X is increasing. That makes sense. Oh, so maybe... What do I print? I print scanning at every position, right? Yeah. So what happens right before it just decides to give up? It scans y22, x is 9. What? It's definitely taller than that. And we see y reaching higher numbers on some earlier rows, right? Y goes up to 78 here. And then 79. And then here it just says, you know what? I'm going to skip from y79. Okay, let's put the tracing for boulders back in. Because maybe something weird was happening every time it hit a boulder? So where's a point where it just decides why I should do something crazy? Here. But nothing happened. It scanned y46, x98, and then said, I'm done. Let's set y to 0. Okay, I guess it must have decided here for some crazy reason. Trace next row after show cur. Whoops. You don't actually need this $sign, right? Because, yeah. Trace string, you can say, if you do this, you're saying, trace this string and attach, but instead return pure unit. If you remove this, you're saying trace this string and instead return pure. And then you call the result of that on units, you get pure unit anyway. So what's happening here? One of these spots where y suddenly jumps. Here, nothing. It doesn't say anything about this. It just stops. It's like, yeah. How? Huh. trace goes to standard error, huh? Okay. So let's maybe look at the very first place something weird happens. It decides to go from 17.0 to 0.1. What? Why? What is at 17.0 that would cause you to behave in such a way? That should be when Emacs says 18.0, I guess. Here. There's a boulder here. Oh no, I know what it is. Okay. This is all a result of my trying to stop errors from happening. Look, if there's a boulder here, right, when we encounter a boulder, we move it to like the northernmost place it can go and then continue looping. But I wanted to say, if the space you're planning to write to is not a boulder, is not empty, then there was a bug. And then I changed it. It's like, oh, well, if you're writing somewhere that isn't yourself and it's not empty, then it's a bug. But the point is, here, I don't recursively... This is a recursive function. It's not an iterative function where I determined the coordinates ahead of time. It might have been nice to do so, but I didn't. So the problem is here we don't recurse. So as soon as we run into a boulder that's next to a wall or another boulder, we just like give up and die and move on to the next row. So I think it's probably about time to get rid of this. And just say, don't bother reading what was there. Because we now believe that part of the function is correct. We'll just overwrite it implicitly. What do you mean couldn't match type? Do. Okay. You got me. It was trying to call this function on this and this, like it was 1,000 arguments. Now that I've told it to do, it knows it's supposed to bind them. So if I now do this, I shouldn't see these crazy jumps, right? There's never an error, and it prints a result that's still wrong. But it gets all the way to y99x0 before iterating. And you can see it's closer to right. A lot of boulders are pressed up against a lot of walls, but sometimes it's just like they don't. Like, right? I mean, look at this one. It didn't quite make it. Why? Actually, wait a minute. It still didn't do all the work, did it? Look, here in the last row, or the last column, it only scanned to Y15. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Updating the vacant chord to Y6, which makes sense. 0, 1, 2, 3, 4, 5, 6. Well, that doesn't seem right. And it didn't even put this boulder in the right place when it found it. So is there another case in here that doesn't loop for some reason? Doesn't look like it. Oh, do I ever print next row after? Does that show up in the input here? Yeah, it's always at Y100. Oh, wait. Why did I was looking at this log and I thought it said that the last thing it did was like Y15 or something. But now I'm looking and it says Y100. Oh, you know what? It's because... Okay, this is my fault. I was mixing like less, which is paging the file. I use tmux to scroll up in the terminal output, which means it shows me whatever was above what less is showing me. But it doesn't page up in the file that less is reading. Okay. So the grid is still wrong. A lot of it is right, but like that character there, for example, is in the wrong place. I guess the very first character that's in the wrong place is this O, right? This is Y0, and we'll like look for its first wall. It found walls at 16 and 17, which sounds about right. Wait. That doesn't look quite right. Okay, hang on. Oh! Okay. When I added the fix... What am I doing? Don't go down there. When I added the fix for... Like I was forgetting to put empties into the slot or something, I wrote it after moving the current boulder. So if you put a boulder into its own place, we write a boulder and then we erase the boulder, and the boulder just vanishes. I noticed that because I looked at this and it was claiming it saw some walls, like that it saw a boulder immediately after the first wall, but I'm like, there isn't one there. It's because I erased it like an idiot. So let's try that. Does this look any better? Okay, this, yeah, it looks like all those O's are pressed right up against the hashes. I like that. So what? Oh, it's at like the end of the list, right? Here it is. 108,918. Didn't I have... What was the number I had before? It was like 105,000 or something? And it was too low? So this is close but higher? Where's my Advent of Code window? Found it. That's the right answer. Okay, okay. I mean, this was not the easiest day for me. Let's delete that. Let's get rid of all this tracing now that we believe... Well, let's get rid of most of this tracing. So I might still want it for part 2. I think I'm comfortable enough actually getting rid of this. And if I need something like that back, I can put it back. I just don't want, I don't know. Let's make sure it still runs. What was my answer? 108918. Yes, this is still correct. We should get rid of debug trace, I guess, and control monad when. We're not using those. Sure. Day 14, part 1. All right, so what is part 2 all about? Yeah, spin cycle. So the parabolic, you've been done in a way that focuses on the beams. To do that, you'll need to move the rocks to the edges of the platform. Fortunately, a button, spin cycle. Each cycle tells the platform rolls it 4 times. They go northwest, southeast. And then after 1 cycle, it'll have done all that. Oh, that's a lot of cycles. A billion cycles? That's too many. Right? There must, I guess, be some point at which it enters into a loop, right? Because even if you could do this, like, do the entire 100 by 100 thing in like 1 millisecond, let's say, a billion times would take 1,000 seconds or like over an hour. So I think we have to just do this until we see the same result at the end of a spin cycle. Then compute the length of the cycle and the modulus of the number of cycles remaining the number of cycles remaining modulus the length of the cycle, then run that many more cycles and then compute it, right? A billion is too much. So I guess I want, oh gosh. I think I need a map from like the assocs of the grid to an int, which is like what cycle it was, right? And it's a little expensive, I imagine, to look up a 100 by 100 grid in a map. Use that as a map key. But like, what else am I supposed to do? I could like compute some more efficient hash key or something by interpreting each row as a 100-bit ternary number. But that's hard. I don't want to do that. And it would be hard to fit it even. It wouldn't fit into an int. And integer math isn't exactly fast either. So let's just hope that putting it in a map is good enough. Strict. Part 2, I mean, it needs to return int, obviously. Part 2 of f's is run st of do. We're just going to copy this stuff from part 1, basically. Let's just copy the whole thing. But instead of just rolling it north, I want to say spin a billion times. You know what, let me copy that from the problem just so I can't possibly paste the wrong number of zeros. Spin that many times G spin takes an int and a grid of s and returns an STS unit. So do I want to do this in, I mean, I think so. I think I want to do this all in one st function, a recursive st function. I'm sure there's a better way to think about it, but spin of spins, I guess, times G is loop of zero? Because we'll track what's happened after 0 spins and then 1 spin and so on. Loop 0 and m.empty, where loop of cycle num and previous's equals I guess do I write a do here already? Does that make sense? Maybe. No, probably not, right? M dot G, no. Prevs. I need to do here because I need to read the grid. Yes. State is read array G. Nope, not read array. Get assocs. Like I need all of them. Kind of sad, but that's life. Prevs. All right, what are the cool functions in data map? I was going to just call like lookup and see. And like pattern match on that, but maybe there's something better. Like a combine function or insertion update. All of these just return the map. Do any of them tell me like whether there was something there? Update lookup with key. The function returns the changed value if it is updated. The original key value if the map entry is deleted? What the? I don't even know what the fuck that means. Alter F is a fairly general function that looks like it might work. You could store the state in the F. So suppose alter F suppose I wanted to return a maybe. Like I want to insert into the map and also get back some information about what was there. Maybe A to F of maybe A. Oh my god. So I would say if there was nothing there, then return like an interesting value. Yeah, I think alter F is a good function. I give it a key and it calls my function from maybe A to F of maybe A, where I get to see whether there was a value at this key before. And I get to put something in the map and also smuggle some information out in a functor of my choice. And I think my functor will be a tuple where the first element is telling me like maybe it'll just be all I really want is to smuggle out a bit. Like, was it there? Well, I mean, that's not true. I want to smuggle out. I want to know what the old key was, right? No, the old value. Because the value is how many steps it took to get there. Yeah, I think alter F is what I want. What a powerful function. It can do so many different things by just saying it works in any old applicative or any old functor even. What an insane function here. It uses alter F in IO to where, like, oh, you're inserting in the map and you just in the middle of the insert prompt the user about whether to put something there. Okay, cool. I mean, the funny thing is, I don't even need the map anymore, right? Once I get a hit, I can just ask what used to be there, and that's the length of the loop, right? You know, let's call this function spin cycle, because I think I'm going to want spin to be a function that spin cycle delegates to just do one iteration of the northeast southwest thing, or whatever order we're supposed to do it in. What order is it again? Northwest, southeast. Oh my god, these counterclockwise maniacs. Okay, so actually, I think I want to say case alter f m.alter f. It takes the function, then the key, then the map. Case alter f. Where's my function, man? Find previous. State. And then the map, which is G. No. It's prevs of. So, given that I will no longer need the map once I find a hit, I think the functor I want is actually either, where, like, left is we're done using the map, here's what the old value was. Left, last seen of, you know, something. Right of new previouses. This is going to be the common recursive case here. I don't actually have a good place to attach the definition of find previous, do I? We'll say insert of cycle, I guess, and then have a function out here. Insert n is undefined. I mean, let's actually define this now, shall we? Insert n, and I need a maybe of a. Insert n nothing, saying it wasn't there before, is right, i.e. we still need the map. Just n, I think. We're going to say, yes, keep the map, and do put something there at the index n. Or put the value n at the index you already determined with alter f, which is going to be state. State is the index, the key. N is going to be the value. And insert N of just P is left of P. We no longer need the map. Just tell me what used to be there at that specific key. Write preves is do, probably. Spin. Which I think is just going to be an action that uses G, basically. I don't need to give it any arguments or look at its result. It just modifies G in place. Then call loop again with cycle num plus 1 and the new cache of previously seen positions. If we did actually see something here, we're getting close to being done. We say do probably let cycle length equal, I think we're just subtracting these two numbers. Like, consider if this is, suppose like spinning did nothing at all. Then the time we just saw this input previously was 1 less than our previous one, our current cycle num. Their difference would be 1, meaning cycle length of 1, which seems correct. Yeah, I think this is right. And cycle length is just cycle num minus last seen. So now we can take, what do you call, like, when you unroll a loop, the leftover? I don't know what you call that. We'll call it a leftover. Leftover equals, how many are there remaining to do? I mean, it's, we want to do times minus cycle num, right? Times minus cycle num. That's how many more cycles we're supposed to run. Take that, mod cycle length. That's how many you actually have to run after doing the cycle some number of times. And then we replicate leftover spin. And then I think we just stop, right? Because the grid will have been modified by that sufficiently well. Spin is, there's some monadic composition operators. Control, it's like it looks like a weird fish. It's got like an equal sign and 2 arrows, but I don't know which direction they point or exactly what it does. Let's see. This is all in monad. Why is functor defined in monad? I don't know. Okay. No. Ah, okay, we're getting close. Left to right composition, right to, oh, fuck. Note how this resembles function composition. Okay, that's probably what I want then. Although this is like this is more natural because it lets me write the stuff in the same order that it's written in the problem, right? So I think this is the function I want. No, that's not how you paste. There we go. Spin is just northwest, southeast. Okay. Roll. Oh, do I really need G? Oh, I don't have composition anyway. I guess I don't need composition after all. What order do I take? It should be roll north, right? And then G is the order that this stuff goes in. Yeah, direction then grid. Roll north G. Roll west G. Roll south G. Roll east G, right? Parse error on equals. Where? Line 109. Oh, yeah, there's two of them there. You got me. Replicate M. Okay. Well, that's also in monad, which I just deleted the import for. I have a list of tuples, or a list of nothings, and I got a nothing. What line is this on? 94 in the equation for spin cycle. Loop 0 empty. I'm claiming oh, do I want replicate M ignore? I guess I do. That exists, right? Yes. It's pointing out that I didn't use N, which is correct. I didn't want to use it. So this type checks. I'm not hugely in love with it, but maybe it works. I assume not. Oh, it's a number. It's pretty close to our original number. Could be, right? I mean, it's in the same ballpark. I didn't hugely fuck things up. Okay, let's see what it thinks. Too high. Well, I mean, how on earth am I supposed to debug this, man? I could run it on the test input, I guess. Yeah. I guess that's what I'll do. Let's actually just call debug on input.test. Well, why wouldn't I just say print this actually? Debug needs to do I/O, but that's fine. Before I start doing that, is there something wrong with like how I'm running spin cycle? I'm saying that if I detect something has been in there previously, like I'm only stopping after an entire northwest-southeast cycle. In principle, you might notice the cycle first after a west or something, but this will be nearly as efficient. So I'm always checking in the map right before I go north, then west, then south, then east. So if I've seen it before, it was after, or it was right before going north, south, west, east, northwest, southeast, whatever. And so doing so again will just retrace the steps that had. So I think that much makes sense. The cycle length is the current cycle number minus when it was last seen. I was supposed to do 1,000 cycles of all four, right? Not like, or a billion cycles of all four, not 250 million of each. A spin cycle tilts the platform 4 times. Yeah, okay. This seems right. So what I want to do is put stir debug.prepare f mapped over this. Is that type check at all? Prepate? No thanks. Prepare? Yeah. So let's just try. Instead of roll north G, say spin cycle. Oh, but here's the thing. Spin cycle currently assumes it will run into a loop eventually. It never just says, oh, I'm done. So I guess we have to do a little bit more. If cycle num is times, then don't do anything. Otherwise, it's this. And now everything's going to indent so far over. This actually I think was in the right place, isn't it? Yeah. Parse error on equals y. Line 101. Oh, that goes there. Okay. So now I just need a file named input.test, which comes from, hello, paste. There you go. That's the test input. The example above, We do need a new line here. Our parser would break. It's very fragile. Oops. So what if I said stack run here? How does it look after one spin cycle? It looks like that. That is definitely wrong. It looks like it rolled south last somehow. Do I have the spin cycle in the wrong order? Doesn't look that way. The last thing it did was roll east. So how could we ever get this after rolling east? I mean, it's possible rolling east just is broken. In fact, when I look at, you guys can't see it, I can see both this string and the one on advent of code at the same time. I only have you set up to look at one window at once. But this input is exactly correct, except it needs to roll to the east. It already did the correct whatever it was, going from north, then west, then south. That's why it looks like the last thing we did is roll south. Everything's up against the south because rolling east just didn't happen. So maybe there's something wrong with how we define a scan to the east. Oh, yeah, this looks like probably a problem. It's probably supposed to be 0, 1, right? Because this is our normal vector. Which, what the hell? Okay, this looks... If we're scanning from west... We want to roll boulders to the east, which means we want to start out on the far right side. Yeah. This is supposed to be like this. What if I stack run now? Now everything is where it's supposed to be after one cycle. And before I try submitting my answer, I just want to check real quick that if I said to spin cycle twice, I also get what they say I should have after 2 cycles. Yeah, that's exactly correct. Okay, great. So this might be the right answer then. Although, didn't I have a number that was too low? I think this one might be even lower. Let's give it a try. North support beams. Is it possible I messed that up somehow? What are we computing here? We're calling the load of the Assocs of G. Yeah, that makes sense. Okay, just checking. It is the right answer! Ah, okay. Well, this was not the easiest problem. I mean, I didn't make it as easy as maybe I could have, but I don't think I did anything that was like way more complicated than it had to be. I predicted we would need to roll in multiple directions, and so I implemented that. Making it much more complicated than just like the idea I had for doing part 1 without rolling anything around. I think I in fact said, you know, might part 2 be roll it like north, then east, then south, then west, and do it 1,000 times. But in fact, it's 1 billion times. So we had... I'd be interested to know how long the cycle is, but not interested enough to go add some debug tracing into spin cycle, I think. We can probably get rid of this debug function now. I don't know. It's kind of nice. We'll leave it in. Yeah, we need replicate M. We need maps. We need to fix that, which was wrong. Embarrassing. This. Actually, let's put that. Get rid of those in the previous commit. Yeah, and then this is all implementing part 2. Yep. Sure. Day 14, part 2. Fix trace. And we'll put that before my previous commits. So let's just make that part of the previous commit, please. And now we just have part 1 and part 2. Nice. Okay, I mean, definitely some complicated stuff happened today. Spent a lot of time thinking about how I wanted to represent directions and coordinates, and I came up with something that I think made sense, which is the obvious representation for directions, and then a separate function that tells you the things you need to know about a direction, which are how to move in that direction, how to move perpendicular to that direction, and where to start a scan in that direction. It's a shame I got this wrong, because when you look at it, it's obviously wrong, but only if you're looking at the right place. Having our coordinates be applicative was nice. We needed to multiply and add them, so sure. I think we did some F mapping. Yeah, here it is. Although I think this was just so that I didn't have... I wrote these negatively, and then I was like, instead of fixing each of them, I'll write this shit. I don't know. It's pretty stupid. Oh well. Anyway, hope you guys enjoyed. Thanks for watching, and I'll see you next time.